So today we are going to do law of sines. That's a new topic for you that you didn't learn in geometry. So law of sines is used to find angles and sides of what are called oblique triangles. And what that means is simply that it is not a right triangle anymore. Oblique means it's not a right triangle. So to be really clear, if it is not a right triangle, can you use Pythagorean theorem? No. You can't do sine, cosine, tangent either because there's not a hypotenuse by definition. Do you get what I'm saying? If there's not a right angle, there is not a hypotenuse. So SOHCAHTOA is also gone. So in order to find the law of sine or to use the law of sines, you have to have three pieces of information. Right. And at least one side. If your three pieces of information that you have are just all three angles, you would never be able to figure out what the sides are. Do you get what I'm saying? Like, if you don't have any of the lengths of the sides, you would never be able to figure it out. So you have to have at least three pieces of information, and at least one of them has to be a side. Now, what I'm going to do right here is recap the entire rest of the unit that we're going to do. We're not going to do all of this today, so don't get overwhelmed. I'm just going to give you an overview of the whole thing. Cool? So 4 triangle possibilities, 1 side and 2 angles. Give you 1 side and 2 angles. No one is allowed to groan when I write this. Those 2 patterns would be angle, angle, side, and angle, side, angle. You're going to be okay. 2 angles and 1 side. It's all that it is. Triangles, guys. Only so much trouble you can get up to with a triangle. 3 sides and 3 angles, okay? You can be given 2 sides and the non-included angle. Non-included means it's not in between. So you have 2 sides and 1 angle, and the angle is somewhere else. It's not in between. So that is side, side, angle. I always think it's funny when people write it the opposite direction. For these 3 patterns, you use the law of sines. But I'm going to keep going and give you like a whole overview of everything. You can have 2 sides and the included angle. What would that pattern be? You have 2 sides and 1 angle, but the angle's in between them. Good. That would be SAS, side, angle, side. And the last option is all 3 sides. So for those, and that's SSS, obviously, that's like the easiest one to identify. For those 2 patterns, SAS and you use the law of cosines. All we're going to do today are these first 2 patterns. That's it. So again, I just gave you an overview of everything, but we're not going to cover it all today. We're just going to do these first 2. So here is your law of sines. A over sine A. Lowercase means it is a side. Uppercase means it is an angle. Equals B over sine B. And so you set up this ratio, and then you can solve for what you're missing. Now, also, C over sine C. Again, you don't want to get too caught up in the letters because delta math is going to use like LMN. Do you get what I'm saying? Like they're going to use different letters, but just make them go across from each other. Lowercase for sides, uppercase for angles. So you want to find angles first, then sides. So angles first, then sides in order smallest to biggest. That actually doesn't matter for the patterns we're doing today, but it will be very important for some of the other patterns. So what I do is I just teach everybody to do it smallest to biggest from the get-go. And then when we get to those ones, it's not a problem. Do you get what I'm saying? Like, so just do it the same way every time. All right, and remember, the smallest side is across from the smallest angle. The medium side is across from the medium angle, and the largest side is across from the largest angle. So that's a way you can kind of check your work. Because if you have like the biggest angle and then like you get an answer that's super tiny, you can be like, hey, wait, like, you know, something is not right. All right, first thing we're going to do is draw a picture. All of my triangles look like that. I don't worry about trying to draw them to scale because it simply doesn't matter. Also, it doesn't matter so much for these patterns, but it is going to matter a lot later on. So I want you to learn how to do it the same way every time. Are you coming with me? Always start with the bottom left. I don't care if it's A, B, or C, but whatever one you're given, start with the bottom left. So what was I given first? A. Put that right here, A26. Then go to the bottom right. What's the next one we were given? B. So put B there. B is 50. And so C has to go at the top. So start at the bottom left, go to the bottom right, and then go to the top. And then we have to have one side. We have baby C, which is 12. So 12 goes there. Baby A goes across from angle A. Baby B goes across from angle B. What is the pattern? I want you to start getting used to looking at it. You have two angles in one side. Good. Why is it angle, side, angle? Why is the side there? Yeah. Do you see how the side is sandwiched in between the two angles? So angle, side, angle. So let's list out what we're missing. This is like your scavenger hunt list. You want to find the angles first. What angle are we missing? C is the one we're missing. And then you want to find your sides from smallest to biggest. So which one out of the two we're missing, which is A and B, is going to be the smaller one? A. Good. Why is it A? Why is it's from the smaller angle? All right, and then B. So we're going to find everything in that order. That's our scavenger hunt list. You do not need to show any work for finding this angle because it's just going to come from the calculator. How much does the whole triangle have to add up to? 180. So I'm going to take 180 and subtract the other two, which is 26 and 50. You see how I did that? I just took 180 and subtracted the others. So that one's 104. So this triangle is not to scale. 104, what do we call an angle that's bigger than 92? Obtuse. It would look like this, but I don't care if it's to scale. That part doesn't matter. All right, now to set up your law of sines, you need a side across from an angle. Do we have that? I mean, we're going to have that, but do we have a side across from an angle? Yeah, this is 12, and we just found this one is 104. So here's how you set it up. 12 over sine of 104. Do you see how I have those two across from each other? Equals. And now what's the one we're missing that we're going to find next? A. So it's going to be A over sine of A, which is what? 26. Now listen for how you type it. You cross multiply. So I'm going to type 12 times sine of 26. And then you divide by the other one. Cross multiply and divide. Do you remember that from algebra? Cross multiply and divide. So watch me type it. It is going to be, let me delete this. 12 sine of, what was it? 26. See how I used parentheses there? I guess you wouldn't need to though, because I'm going to just divide the whole thing. Divided by sine of 104. There we go. 5.421. Now, when I go to set up to find B, watch this. This is great. Do you see how it started 12 over sine 104? You're still doing the same problem. It hasn't changed. So, like, hey, Miss Cole, it looks like you just rewrote the same thing. Sure did. But now you have to put what you're looking for on the other side. So this side is going to be B over sine of whatever B is, which is 50. So you cross multiply and divide. It would be 12 sine of 50. You multiply these two and then divide by sine of 104. I'm not going to type it all over again. What do I just have to change in here? No, the 104 is going to stay. Yeah, the 26 has to change to a 50. So 9.473. Now, hold on a second. Does that make sense that this number is bigger than that number? Why? A's angle is smaller than B. Okay, go ahead and draw a triangle. It does not need to be to scale. Just draw something with 3 sides. In fact, it's not going to be to scale because do you see how A is 110? And that would be like this. You can draw an obtuse triangle if you really want to, but I'm not here to grade your art. All right, where did I tell you to start? Bottom left. Good. You guys listen to me, and that's perfect. And I don't care what it's called. In this case, it's called A. It could be called Q. It really doesn't matter. But start at the bottom left, then go to the bottom right. The other one they gave us this time was C, 25. And then the one we don't have goes at the top, which is B. And then we're given baby A, which is 19. That goes across from angle A. So this is 19. This is baby B. This is baby C. So what is our pattern? You want to look at what you have labeled. We have these 2 angles and then this side. Yeah, it's angle, angle, side. Hey, Ms. Cole, what if I wrote SAA? That's fine. It doesn't matter. It's totally fine. What's important is that the side is not in between the angles. That's the only thing. All right, let's list out what we're missing. What are we going to find first? Angle B, good. And then out of the 2 sides, B and C, which one will we find first? Why C? Smaller, and then B. How will I get big B, the capital B, the angle? Because that's the easiest one. I don't even need to write anything down for that. Yeah, 180 minus the other 2, right? Oh, good. Somebody's got a calculator in their head over there. 45. With me here still? Feel like I've lost everybody. Are we still? Yeah. Okay. So to set up your law of sines, you need a side across from an angle. Have we got that? Do you have a side across from an angle? Yeah. Yes. Do you see these 2? All right. So it's going to be 19 over sine of 110. And in fact, if you want to just go ahead and write that twice, sometimes people will like to do that because you're going to use it twice. So you may as well. 19 over sine of 110 equals, now we're going to find C next. So on the other side, it would be C over sine 25. All right, how am I going to type that? Cross multiply and divide. Okay, so you guys tell me, what am I going to type? Yeah, 19 sine 25 divided by sine 110. 8.545. And then to do the other one, what am I going to need to write? Yeah, B over sine of whatever B was. We found it right there, 45. So yeah, in my calculator, all I'm going to do is change the 25 to a 45, and we should get a bigger number, which we did, 14.297. Usually at this point, everybody's starting to get it. I'll probably just do one more. And then we've got a couple of other little area formulas to do. And we'll call it a day. Because I think usually at this point, everybody starts to be like, okay, we got it. Why don't you guys go ahead and try and do the labeling on your own, and then you can make sure it matches mine. I'm going to pause the recording real quick. All right. Does yours look kind of like that? Well, exactly. It needs to look exactly like that. So 50 goes down here. A, B is 72. Angle, side angle. Sweet. All right, let's make our scavenger hunt list. What are we finding first? C. Good job. Big C. Angles first. All right, and then which one? Little a. And then baby B. Good. See, you guys are getting it. All right, so to do the angle, you're just going to do 180 minus the other 2. I got 58. Calculators are great, but if you type one thing wrong, then it's wrong. And I'm always nervous I'm going to type something wrong. So make sure you keep after me. All right, you need a side across from an angle. Do we have that? This is our one side we have. Yeah, and then we have to reuse that. So 12 over sine 58, and you can even just go ahead and write it twice if you want to, because you're going to use it twice. So for the first one, we're looking for a first. So it'll be a over sine of whatever a is, which is 50. And so I am going to type 12 sine 50 divided by sine 58. 10.839. You guys will get practice typing this when you do your classwork. That's the point of that. All right, and then the last one, it'll be b over sine of whatever b is, which is 72. And so I'm just going to go back and change the 50 to a 72. And I should get a larger number, which I did. 0.457. I'm going to not do 4 and 5 if you guys feel like you got it. Is that good? Okay, sweet. Hey.
So for the AC, if we forget to put the degree sign.
No, that's fine. I mean, it's wrong. The whole thing's, oh, I'm just kidding. No, totally fine. All right. Oh, yeah. So we have two different area formulas to get an area of a triangle. I'm going to write the word area because if I just write a capital A, can you see a problem with that? Okay. Yeah. So there's three different sort of like versions of this. 1/2 AB. Whoops, I meant for that to be a B. Sorry. Can't talk and write at the same time. Let me write it and then I'll say it. 1/2 AB sine C. But if you're given different information, you can just adjust the triangle, like twist the triangle. And again, don't get caught up on A, B, and C. It might be RST, all right? But another version of that would be 1/2 BC sine A. Like, look at that and let that sink in for a second. Do you see what I did there? How I just jumbled the letters? Because there's a third version, which would be 1/2 what? What's the version I didn't do yet? AC sine B. Please do not try to memorize those as three totally different things. They're all the same. And again, if the triangle had different letters, it would be 1/2 RQ sine of S. Do you understand what I'm saying? It just depends on what you're given. All right, the other one is called Heron's formula. Everything in math either is exactly what it sounds like or it's named after the person that did it. I actually really like this formula. It's interesting. It geeks me out. I realize I'm a nerd, but it's just interesting to me that this works. If you don't have any angles, if all you have are sides, what you do is first you get this S value. I don't like that he called it S because S's look like 5s. But what you do is you add up all the sides, A plus B plus C, and do half of that. This is so crazy that this works. How he figured this out, I have no idea. But you add all the sides, if you take a triangle and add all the sides together, do half of it, your area equals, you're going to put a gigantic square root. It's not that complicated, just hold on. You take that magical S number that you just came up with, and then it's times S minus A, S minus B, S minus C. And that will give you the area of the triangle. How does that work? Do you know what I mean? Like, and how did he figure out that that worked? Like, did he just sit there long enough to, I don't know. Yeah, but it works. Any triangle, if you have the three sides and you do that, you get the area. You don't even have to have any of the angles. That geeks me out that works. But anyway, we'll just try 2 of these. Let's just do 6 and 8. We don't need to do a whole ton. Now look, do you see how you're given 2 sides and 1 angle? Do you see that there? Okay, so since you have an angle, you're going to do this one. And it's going to be this version of it. Do you see? Why would it be this version of the? You have angle A, okay? But it's going to be 1/2 times 10 times 12 sine of 22. That's it. I'm going to slam that in the calculator, bless you, and we're going to get our answer. So your job when I'm typing is to make sure I don't type anything wrong, okay? Because if I type one thing wrong, this is going to be wrong. And 22. 22.476. Now, real quick, for areas, and because I will take off if you don't put this on your test. Say all of these were in feet. It's feet squared. Why? Area, it's two-dimensional. Not that this will be on there, but just for the sake of knowing it, volume is cubed because it's three-dimensional. Do you get what I'm saying? You fill something up. All right, and then we'll do 8. Do you see how this is all 3 sides? You don't have any angles? You're going to do this Heron's formula. The first thing you're going to do is get that S value. It's 1/2 of just adding them all up. You add them all together and do half of it. What is that, 53 divided by 2? Did I do that? Sure. Just going to trust me? I'll just type it in then. Use your calculator. You're allowed a calculator for like the first time. Is it 53? And then half of that, 26.5. Yeah, I just typed it in. So your area, you're going to draw this great big square root, and underneath that, you're going to have 26.5. And then what I usually do is just draw 3 more blanks. You're just going to take that 26.5 and subtract each of these other numbers. So 26.5 minus 12, what would that be, 14.5? 26.5 minus 16, what would that give us? Yeah, 10.5. And then 26.5 minus 25 be 1.5. And then I'm going to type all that in. Do you know how to type a square root in here? Yeah, you can either do SQRT or it's in here. Right there. All right, so let's see. 26.5. Oops. Again, your job is to make sure I don't type anything wrong here. Please stay focused for like 10 more seconds here. Oh, yeah, see, 105, that would not be right. There we go. 77.794. And again, I didn't give you units, but if there were, it would be whatever squared because it's an area.